Hello everyone! Let's take a look at this problem. We are given a speed-time graph that tracks a journey over 60 seconds. The question asks us to calculate the total distance traveled. This is a very common type of question on the SAT. The key is to know the relationship between a speed-time graph and the distance an object travels. Let's dive in and break it down. First, let's understand what we're looking at. The graph shows that for the first 10 seconds, the speed increases. Then, from 10 to 30 seconds, the speed stays constant at 10 meters per second. Finally, from 30 to 60 seconds, the speed decreases back down to 0. The question is about the total distance. Exactly. The most important rule to remember here is that for any speed-time graph, the total distance traveled is equal to the area under the graph. So our task is to find the area of that shape between the blue line and the horizontal axis. The shape under the graph looks a bit like a house, which is a bit complex. To make our lives easier, we can split this large shape into smaller, more familiar shapes. As you can see in the diagram, we've divided the area into 3 parts: an orange triangle on the left, which we'll call A1, a green rectangle in the middle, A2, and a purple triangle on the right, A3. So our strategy is set. We will calculate the area of the first triangle, A1, then the area of the rectangle, A2, and finally the area of the second triangle, A3. Once we have these 3 areas, we'll add them all up to get our final answer. Let's start with A1. All right, let's focus on the first section, A1, which is the orange triangle. This represents the first 10 seconds of the journey. To find the area of a triangle, we need its base and its height. Looking at the graph, the base of our triangle runs from 0 to 10 seconds, so its length is 10. The height goes from 0 up to a speed of 10 meters per second, so the height is 10. The formula for the area of a triangle is 1/2 times base times height. So we calculate 1/2 times 10 times 10, which gives us 50. This means the distance traveled in the first 10 seconds is 50 meters. Next up is the middle section, A2, the green rectangle. This part of the journey is from 10 seconds to 30 seconds, where the speed is constant. Calculating the area of a rectangle is even more straightforward. For a rectangle, the area is just width times height. The width is the duration, which is from 10 to 30 seconds, so 30 minus 10 equals 20 seconds. The height is the constant speed, which is 10 meters per second. So the area is 20 times 10, which is 200 meters. That's the distance for the middle part of the journey. 2 down, 1 to go. Now for our final piece, A3, the purple triangle. This represents the last part of the journey, from 30 seconds to 60 seconds, where the object is slowing down and coming to a stop. Just like before, we use the formula 1/2 times base times height. The base of this triangle is the time interval from 30 to 60 seconds, so its length is 60 minus 30, which is 30. The height is still 10 meters per second. So we calculate 1/2 times 30 times 10, which gives us 150 meters. We've done it! We have the distance for all 3 parts of the journey. A1 is 50 meters, A2 is 200 meters, and A3 is 150 meters. The final step is to add them all together to find the total distance. Let's do the final addition. 50 plus 200 is 250. Then, 250 plus 150 gives us a grand total of 400. So the total distance traveled during the entire 60-second journey is 400 meters. And that's our final answer. By remembering that distance is the area under the speed time graph, and by breaking that area into simple shapes, we were able to solve the problem step by step. The total distance is 400 meters. Great work, everyone!